Hello, welcome back to LIVENODING. I have this setup right here that's basically it's using the math function greater than uh, expression again, but I'm gonna show you really quick. If I animate this from 0 to 1, you will see what's gonna happen in 3D scenes. It's basically some kind of 3D volumetric um, voxel that's kind of building out. So yeah, so what is this exactly? This is actually, I started with a vector p field, and by default, vector p field, this will generate points. And these points is gonna spread in a based on this unit value, and then this is the number of points that you generate. But if I pipe this into the vector noise, I have this multiplier here. Don't worry about multiplier too much. But if I pipe the vertices into vector noise, it's gonna generate a 3D noise data, right? In 3D space. And if I'm using this greater than functions, it's gonna turn it into true or false data that I can use to mask out the original vertices. So this is where the magic happens. This is the original points data, and this is where I'm masking it out. If I get rid of the box and just look at the points data, turn off the original, so you can see just bunch of points. I can increase this a little bit more. So now you can see almost like a volumetric data, like a point cloud of 3D noise. I can still adjust this volume, and I can also multiply with scalar, but it's all happening in real time, right? You can see the data, you can see what's going on with the noise. You can switch to other functions like Voronoi. With Voronoi, of course, you get like more like a bubbly kind of effects. You can go even further. Let's try 50 by 50 by 50. That will be like 125,000 of points. That should be kind of the limit of what maybe my computer can do. I don't know, maybe I can go further. But anyhow, let's go back to Perlin noise. And now you can see the volumetric kind of voxel kind of effect. And based on these vertices, of course, you can generate boxes. And if you are using instancing, it's going to be a lot faster. But I'm going to show you that you can use matrix apply and pipe in the box there. And it's going to be a really big data. I wonder, maybe I should use smaller value for now. Let's reduce this to 5 by 5 by 5. Plug this into the matrices and join them. So we're gonna have a single objects and use different color. Turn off the points. So this is our representations of 3D noise. It's pretty boring unless we increase the number back to 20 by 20 by 20. Now we have a voxel. Well, we have to ensure that they're not overlapping, but you get the idea. From here you can really remesh it, and then you can perhaps even 3D print it. So bake it out. So you have this guy right here, and from this guy, a single objects, we can use Remesh Modifier. Remesh will handle everything magically. So let's try and see how far we can push this. Scale. Well, maybe they should be overlapping after all. So let's try that. This size 1.2, 1.1, 0.6, 0.3, Let's make them kind of overlapping a little bit. So that should be nice. Bake it out. And then remesh from here. Turn off remove disconnected pieces. And let's get a smooth one. I have a feeling that we need to do at least one time Boolean in order for this to work. Because at the moment, I think Remesh kind of look at it, hey, you have like a bunch of objects here and you probably want to join them together before you are doing the remesh. So I think that's possibly what's for best outcome of this result. So I think I'm gonna stop right here, but it's kind of interesting from here, from the perspective of to be able to do this so easily, and it's just simply by using this greater than and the vector, and then kind of use it to mask out a vector, a 3D field of vector points. You know, it's all pretty abstract, but then once you understand this, it's become really pretty easy to understand, and you can visualize 3D voxel basically. And from here you can actually 3D print like a smoke simulations. I'm pretty sure that's possible. You definitely need, perhaps you need to use like a particle simulations, get the smoke happening, and then bring that data into sphere chalk and then try to remesh it this way. It's probably gonna be interesting. So there is a Blender add-on that's currently on the work. I think it's to kind of like remesh water simulations. I am looking forward to try that add-on, but for now I think this is a kind of one way we can remesh 3D volumetric or any kind of volumetric data. So yeah, it's a pretty interesting and definitely something you can try. You can, of course, at any point in time replace the box with anything, not just the box. You can use any of this cylinder whatsoever. So that will replace every point that you see here with that object. So based on this cloud 3D volumetric points data and the masking using vector noise, you can get this interesting result. So there you go. That's another look at 3D voxels and how a simple masking using greater than functions can give you an interesting result. So there you go. Thanks again for tuning in, and I'll see you next time. Bye.